Chapter 3, Lessons 1 and 2 will be combined for this video. They are on constant rate of change and slope. And for the purpose of this, we want to make sure that you understand that constant rate of change and slope are related concepts that actually mean roughly the same thing. What I mean by that is when you find a rate of change, you are actually also finding the slope of a line. Let's talk about these definitions. First is linear relationships. Those are relationships with straight line graphs. By that, what we mean is relationships are anything that relates numbers together. And in this case, you guys, for this chapter, will see equations. You will see tables of numbers. And you're going to have coordinates on a graph. Those will be our relationships that we're going to analyze and decide whether they are straight lines or not. Constant rate of change is when the rate of change between points is constant, meaning that they have a pattern where they are either increasing or decreasing, so addition or subtraction, by the same number. And we'll look at what that means. We have slope, which again is a rate of change, but we use it to talk about the steepness of a graph. One of the examples I use is we've all done that thing on a playground that your parents tell you not to do, and that is to run up a slide. Well, when you run up a slide, we know it's easier to run up a slide that is less steep. It is more flat versus the slides that are steeper. And that's the same idea. We're going to be talking about graphs based on their steepness and which direction they're going in. To determine slope, we need our rise, which is our vertical change, or our change in our y values, and our run, which is the horizontal change, so left to right, and that's our change in x values. What might be helpful to note is when I have a graph, you guys will always see your two axes. We have the x-axis and then the y-axis. Things we'll need to know are that for the x-axis, it is positive to go to the right, but negative to go to the left. It is positive to go up on the y's and negative to go down on the y's. And we're going to use that when talking about putting points on a graph and about determining slope based on the direction of the coordinates. We're going to start by looking at a table of numbers. The balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? If so, find the constant rate of change. If not, explain why. Here's what we need to figure out. Looking at this table, I need to figure out if my numbers are changing at a constant rate. Now, I want to be sure that I let you know that when talking about a table of numbers, we're still talking about x's and y's. Your left column is always your x, your right column is always your y. And let's look at how the x numbers are increasing. I'm starting at 3, going to 6, 9, and then 12. So that means these are increasing, so plus 3 each time. So the x values are increasing by a constant rate. Let's check out the y's. From 170 to 140 to 110 and then to 80, we are reducing by 30. So I'm going to put minus 30. This negative sign is important because rate of change can be talked about in terms of numbers getting smaller or getting negative. Since both sides are constant, we can say that this relationship is linear. Now we need to find a rate of change. To find a rate of change, what I need to do is find the change in my y number and my change in my x number. And you've already found that by just figuring out whether it was a constant rate of change or not. My change in y is the negative 30, whereas my change in x is the 3. This reduces down to negative 10. I'm going to talk about what this negative 10 stands for. In this relationship, this negative 10 actually means that my balance decreases by $10 for every one transaction. So if you're ever asked to interpret your rate of change, you're being asked to give a description of as one thing increases or decreases, then this number increases or decreases. Let's find the rate of change for these two relationships as well. If they are not linear, we'll then need to make an explanation. Let's talk about the cooling water. My x values are time, and for time, when we look at it, it's always going to be constant. Time does not change in terms of its rate. For the y's, I have minus 5, then I have minus 4, and minus 4. So notice that this time, your y's are not constant. So I'm going to say not linear, and my explanation, and we're going to give a reason. That reason is as the time increases, the water does not cool since the temperature is going lower, at a constant rate. Now let's go over and look at the graph. To figure out whether a graph is linear or not, we're going to count how far up and down and then left and right you have to move to find the next point. So I'm going to start here with this point, and I notice that my points are going down. Well, I have to go down 2 spaces, but what I want you to notice is they didn't count by ones when they made this graph. They counted by tens. So actually, I went down 20. So that's minus 20. From here, I have to go to the right 2 spaces. But again, they didn't count by ones here. They counted by fours. So I went to the right, so positive 8. I'm going to do the same thing again. I went down 2 spaces for minus 20, and then right 2 spaces for plus 8. So this is a linear relationship. We could see that from the picture to begin with. And its rate has already been found. It's going to be, again, the change in y over the change in x, also called rise over run. That's negative 20 over 8. And we're going to go ahead and reduce this. I'm going to divide them both by 4. For a fraction of negative 5 over 2. And we're actually going to keep our rates of change in slope as fractions. They can be improper, but it's harder to work with mixed numbers when talking about slopes of lines. And same thing with decimals. We'll save decimals for if we're talking about money. Use the table to determine if there is a proportional linear relationship between a temperature in degrees Fahrenheit and a temperature in degrees Celsius. So here we have something different going on. We're talking about proportional. And for proportionality, I have a couple requirements. First, I'm going to see if this is linear. After we find that, I'm going to find whether this crosses the origin, meaning the point 0, 0. So let's first test whether it is linear. My x's, or my degrees Celsius, are increasing by a constant rate of 5, while my Fahrenheit, or my y values, are increasing by 9. So I have a linear relationship with a rate of 9 over 5. Now, the case of figuring out this crossing at 0, 0. I'm going to look back at the chart, and I want you to notice that 0 is actually one of my numbers. Right here at 0, 32. This represents the ordered pair of 0, 32. Well, that means, even though it is linear with a rate of 9 over 5, this is not proportional because it does not cross 0, 0. Now, this is not the only way. Another way of doing this would be to look at ratios between the points. Such as, I could look at the 10 and the 50. If I make a ratio that is my y over x, I want to see if they are all the same ratio. For example, if I start with the 50 over 10, that equals 5. But what if I pick the 68 over 20? And when I reduce that, I get 17 over 5. And is that going to equal 5? It won't. It will equal 3 2/5. And since 5 does not equal 3 2/5, it is, and that's an arrow here, not proportional. Most likely, we're going to use a strategy that helps us figure out if the graph crosses at 0, 0. The proportions, the ratios, help us if we don't have any other options. Use the table to determine if there is a proportional linear relationship between mass of an object in kilograms and the weight of the object in pounds. Explain your reasoning. So we're going to go through the same process. My x values are increasing by 20, where my y values are increasing by 9. So this is linear with a rate of 9 over 20. And now we're going to figure out whether it's proportional. One way is we could count backwards. And what I mean by that is I know my points are all increasing by 20 and then increasing by 9. But what if I take that pattern backwards and I subtract? Well, that's 0. And if I subtract 9, that is 0, which tells me that this is, in fact, proportional. Because it'll cross 0, 0. And again, the other way could be the ratios. And if I look at a couple, say 27 over 60, that's 9 over 20. 18 over 40 is also 9 over 20. And I know that 9 over 20 itself equals 9 over 20. So they are all the same ratio, making it proportional. Now we're going to get into slope. Slope, again, is finding rate of change. We have rise over run. We have our change in y values and our change in x values. Important to know is that we use the variable m to represent slope. That's going to come into play when we start looking at equations. Also, when I talk about the slope between 2 points, we're going to label them as x1, y1, or my first point, and then my x2, y2, which is my second point. Before we get to those, let's look at these two examples of slope in your real life. I have this treadmill, and we can actually turn this into a triangle. And this triangle has a slope. If I talk about rise over run, think back to the definitions at the front. That's the vertical change over the horizontal change. And so for this example, it is 10 over 48. We reduce this fraction to say 5 over 24. We could also have a description in words. It says a hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope of the hiking trail? So it's describing a change like this, where it's 6 feet and then 100 feet. And we're going to find the slope. Well, slope, or rise over run, equals 6 over 100, or reduce your fraction to 3 over 50. We're going to look at finding slope with a few other relationships. I have a table here, and I want to figure out from this table that shows the number of pages Garrett has left to read after a certain number of minutes, so the points lie on a line, and we want to find its slope. Since I don't have a line written, my slope is going to be my rate of change. So slope equals rate of change. So that's going to equal, let's see, this is plus 2, this is plus 2, and then plus 2. My y's are going down by 3. So my slope, or rate of change, is -3 over 2. And something I want to note is that since we're talking about this fraction as kind of a single number, when I have a negative on top of a positive number, it just makes the entire fraction negative. We also have a graph. And for this graph, we just look at the rise and the run, which they already have marked. So 1, 2, 3. Since I counted up, that is plus 3. And then 1, 2, 3, 4, plus 4 because I counted to the right, giving me a slope of 3 over 4. The last way of finding slope is going to use a formula that we call the slope formula. And it states that the difference in my y values divided by the difference in my x values is going to be my slope. We're going to start by labeling my points. So if I look at this as steps, label your x1, y1, and then your x2, y2. So x1, y1, x2, y2, or my first and second points. Second, I'm going to plug it in. So for this equation, here's what I'm going to do. Let's start off with y2, which is 3. Let me erase that so no one thinks it's a different number. Minus y1, which is 2. Then I have x2, which is negative 4, minus x1, which is 1. Now all I have to do is solve what I have left. 3 minus 2 is 1 over negative 4 minus 1 is negative 5, giving me a slope of negative 1/5.